Hi, this is Mrs. Young, and this video is a review of the last two lessons that we covered: surface area of prisms and cylinders and surface area of pyramids and cones. So I'd like you to get out your spiral and work on your bell ringer here. There are three problems. The first one is a composite figure where we're putting two cones together. Remember in our composite figures that they are hollow in the middle, so there are no bases on either of those cones. So you have a cone on the left, a cone on the right, and again, it's hollow in the middle. The second one is a square pyramid, and then the third one is a cone. So again, I'd like you to pause the video now and find the surface area of each of these three shapes. So again, pause it. Okay, so for number one in your bell ringer, the cone on the left is 12 pi and the cone on the right is 12 pi. Add them together, you should get a total surface area of 24 pi. The second one for the square pyramid, the lateral area is 1/2 times the perimeter of the base times the slant height. So 1/2 times 4 times 9 is 36, slant height is 12, so 216 is your lateral area. Then for our total surface area, we take the lateral area plus the area of the base. Well, if the base is 9 feet on each side and it's a square, 9 times 9 is 81. So the lateral plus the base gives us a total surface area of 297 for that square pyramid. And then in number 3, for our cone, again, the lateral is pi RL. So I have 24 pi for the lateral. And then my base is a circle, pi r squared, so 64 pi for that circular base. Add them together and my total surface area is 88 pi. So again, lateral 24 pi, total surface area 88 pi. Again, today is just kind of a review, so we're going to just do a couple problems practicing our surface area. This one right here kind of always reminds me of a house shape. You have a box on the bottom and a pyramid on the top. And again, remember that it's hollow in the middle. So that box on the bottom, you have the lateral of that box and the base of that box, but there's no top on that box. For your pyramid, again, you have the lateral or the triangles on your pyramid, but there is no base on that pyramid. So again, I'd like you to pause the video and go ahead and try to find your surface area of this composite figure. Again, make sure you're showing work and coming up with an answer. So go ahead and pause it and find the surface area. So for this composite figure, your box has a surface area of 48 meters squared, and then the pyramid has a surface area of 32 meters squared. When I add those two together, I should get 80 meters squared. As far as our composite figures go, this one is relatively easy. I did it by finding the surface area on the box of the right side and the left side, and then I found the area of the front and the back, and then the base, the square at the bottom, and I added those up. Another thing that you could have done is found the lateral of the box, right? The perimeter times the height, give me the lateral, and then add in the base. That's just another option. So there's a couple different ways that you could show work, but make sure you're showing work and I know how you're coming up with the answer, like what formulas you're using. Okay, so on to our next practice problem. This one is finding the lateral and surface area of a pentagonal pyramid. Again, remember that a pentagonal pyramid has a base that's a pentagon. And to find the lateral, we're going to start with that. To find the lateral area of a pentagon, we take 1/2 times the perimeter of the base times the slant height. So this is the easy part. So again, I have 1/2 times the perimeter of the base. Again, the base has an edge length of 9, and there are 5 sides to a pentagon. So 5 times 9 is 45. And then my slant height, which they labeled it right here, my slant height is 18. So again, this is where you want to pull out your calculator or your phone, whatever you're using, multiply those together. You got 405 as your lateral area. So 405 meters squared. That's the lateral area of our pentagonal pyramid. Now we want to find the area of the base. Well, our base is a pentagon. So again, we have a pentagonal base. So a pentagonal base, we have to think back to that unit that we just did on area of different types of polygons. I'm going to go ahead and draw a pentagon here, try to make it a regular pentagon. And we know that it's 9 meters on each side. I'm going to put the center here and draw a central angle. So if I take 360 divided by 5, I think I get 72. And then when I draw in the apothem, I cut that in half. So I get an angle of 36 degrees right here, 36 degrees. I'm going to have to use trigonometry, right? So again, if the length of the whole side is 9, half of that is 4.5. So then we know that in our trigonometry, we're trying to solve for the apothem. So we can say opposite over adjacent, that's tangent. So I'm going to say the tangent of 36 is equal to the side opposite, 4.5, over the apothem. So again, this is where I'm going to ask you to pull out your calculator, solve for the apothem. Then remember that the area of a pentagon is 1/2 times the apothem times the perimeter. When you get a value for the base, I want you to add it to the lateral to come up with your total surface area. So again, we want this to the nearest 10th. So go ahead and pause the video, use your calculator, come up with the area of the base, add them together, and get your total surface area. Pause. So you should have come up with the area of the base is 139.36. Again, I try to carry this decimal through on my calculator, try not to round it too soon so that we're not rounding and being off by a little bit. When I add that area of the base to the lateral, I get a total surface area of 544.4 meters squared. So again, that's finding the lateral and surface area of a pentagonal pyramid. Next, I'm going to ask you to find the surface area of a regular triangular pyramid with a base edge length of 12 inches and a slant height of 6. Notice that I want the exact answer and rounded to the nearest 10th. Remember that if it's a regular triangular pyramid, if the base is a regular triangle, that's a equilateral triangle. So you might have to do something with special right triangles when you're finding the area of that base. So again, go ahead and pause the video and take a minute or two and find the surface area of this regular triangular pyramid. Okay, so for my regular triangular pyramid, my lateral area is 1/2 times the perimeter of the base. 12 times 3, that's 36. And then the slant height is 6. So your lateral area is 108. That part's easy. The tricky part is finding the area of the base. Again, if the base is a regular triangle, it's going to be an equilateral triangle. If it's 12 inches on each side, half of that is 6. So then the height of the triangle, the long leg of that 30, 60, 90 triangle is 6√3. So again, to find the area of a triangle, it's 1/2 times the base times the height. So you have 1/2 times 12 times 6√3. So that gives us 36√3. That's the area of our triangular base. Adding our lateral to our base, we come up with 108 plus 36√3. Again, 108 is our lateral, 36√3 is the area of the base. You cannot combine those two terms. One has a radical in it, the other doesn't. They're not like terms, so you cannot combine them. And then to get my rounded answer to the nearest 10th, I just plugged this into the calculator and I got 170.4 inches squared. So again, 170.4 inches squared. Our last problem for today is another composite figure. I think this one's a little easier. I think boxes are a little easier. Again, remember that in our composite figures that they're always hollow in the middle. So the box on the bottom has a lateral area, a rectangle on the base, and it does have this rectangle on the top, but you're going to have to subtract out that smaller rectangle from the top. Again, it's hollow in the middle. For your rectangular prism on top, again, you have the lateral area of that rectangular prism on top. You have a top surface, a rectangle, but you don't have a bottom surface. So again, remember that they are hollow in the middle. So I'd like you to pause the video and take a couple minutes to come up with the surface area of this composite figure. So for my composite figure, for the box on the top, my lateral, again, the perimeter, 21 plus 18 plus 21 plus 18, that's 78 times the height is 9. So 702 is the lateral, or the distance around the middle of that box on the top. And then the top of the top box is 21 by 18, that's 378. So if I add those two together, the box on the top has a surface area of 108. Again, there's no bottom to that, it's hollow in the middle. For the box on the bottom, my lateral, 35 plus 20 plus 35 plus 20, and then multiply that by the height, which is 15. So I should come up with a lateral of 1650. The bottom of that box is, both the bottom and the top, 35 times 20 times 2 is 1400. And then I have to subtract that rectangle off the top of the box on the bottom. There's an opening here, so that's why I subtracted that 378. So again, the lateral of the box on the top plus the top of it, the lateral of the box on the bottom, the top and bottom of the box on the bottom, minus this rectangle from the top of the bottom box. So that comes up with a total surface area of 3,752. I'm just pointing out to you here in the green is that when I add in the top of this box, it's actually the same that I subtract from the bottom of this, or from the top of the bottom box. So those two kind of actually cancel each other out. So again, total surface area 3,752. This is a shorter video for today because it's just a review of surface area. Your homework tonight is going to be a worksheet that has 7 problems on it. It is a worksheet on surface area. So there's 7 problems total. I'm going to post it in Google Classroom. You can either print out the worksheet off of Google Classroom, do your work and take a picture and submit it, or you could, if you don't have a printer, draw the pictures in your spiral, take a picture and submit it. Or I'm also going to post it as a CAMI, which means it's an electronic form that you can write right on. If you can write on your touch screen, like with a stylus, you can show your work that way too. So I'm giving you a couple different options when I post this in Google Classroom for homework. So again, it's a worksheet that has 1, 2, 3, 4 problems on one side and then 3 problems on the back side. The reason I put so much space on here is because I do need to see the work and a breakdown of how you're coming up with these answers. So make sure I know, like, what's the top and what's the lateral and what's the base and what am I looking at? Make sure I know what you're doing. So again, that's our homework for tonight, is a worksheet, 7 problems on surface area. Thank you.